Okay, so let's say, for example, I wanted to integrate from 5 to 6, 2x plus 7 over x plus 2 times x minus 1 with respect to x. Okay, so x plus 1 and x plus 2.
X minus 1.
Oh, definitely. Oh my goodness, what is it with me and signs today? Okay, are non-repeating distinct factors. Okay. Okay, so since they're non-repeating distinct factors, 2x plus 7 over x plus 2 x minus 1 will equal a over x plus 2 plus b over x minus 1. Okay, so the first thing you're going to do is you want to get your common denominators. Okay, which means that 2x plus 7 over x plus 2 times x minus 1 actually equals, I'll give that a little bit of space, a over x plus 2, b over x minus 1, multiply this one by x minus 1 over x minus 1, and this one by x plus 2 over x plus 2. Okay, so if you multiply each term by their common denominator, they actually would just cancel out. If you multiply all of these by x plus 2x minus 1, you just end up with 2x plus 7 equals a times x minus 1 plus b times x plus 2. Okay, so this is where we use what they call selective substitution. We want to be able to solve for a and b. Yep. Okay, so starting off, well, actually, let me put a note. Well, not select, more strategic substitution. Okay, we're going to let x equal 1, then solve for b. Then let x equal negative 2, and solve for a. So let x equal 1. Okay, so if x is equal to 1, that gives you 2 times 1 plus 7 equals a, bless you, times 1 minus 1 plus b, 1 plus 2. Okay, so just like we planned, that a disappears. And we're left with 2 plus 7, which is 9, equals 3b. Okay, divide both sides by 3, you end up with b equals 3. Okay, so now we do the same thing to solve for a. If we let x equal negative 2, which should get rid of the b. Okay, so that means 2, and I'll put it right next to it since it's already there. 2 times negative 2 plus 7 equals, kind of separate that a little bit, A times negative 2 minus 1 plus B times negative 2 plus 2. Okay. Just like it did before, negative 2 plus 2 is 0, so that one disappears. Okay. So we end up with negative 4 plus 7 is 3, equals negative 2 minus 1 is negative 3, A. Okay. So that means that A is equal to negative 1. Okay, so we have our B, we have our A. Okay, so now we get that, and we plug it right into what we have up here. Okay, so instead of the integral from 5 to 6, 2x plus 7 over x plus 2x minus 1 with respect to x, separate that a little bit, that's going to equal, for your A, it's going to be negative 1 over x plus 2. The integral of that from 5 to 6. Plus, and for B, 3, so that would be 3 over x minus 1 with respect to x. All right, so if we integrate both of those separately, and I'll just move that over a little bit, bring that negative 1 down, it's actually negative natural log the absolute value of x plus 2, plus, bring our 3 down, 3 times the natural log of x minus 1 from 5 to 6. Okay, so if we go ahead and plug those in, negative natural log, 6 plus 2 is 8, plus 3, 6 minus 1 is 5, minus, plug in 5, negative natural log of 7, plus 3 times natural log of 4. Running out of rooms. I should be able to finish this one here. Okay, so we have negative natural log of 8. Actually, we should be able to combine these two. Okay, so we know that since 4 is equal to 2 squared, and 8 is equal to 2 to the third power, you have negative natural log 2 to the third. Remember, that 3 is just going to come down to the front, plus 3 natural log of 5, plus natural log of 7, plus 3 natural log of 2 squared.
Wouldn't it be minus 3 natural?
Oh, yep, minus. I am just allergic to the right signs today. All right, so remember that 3 comes out front, and of course I'm running out of room. So you have negative 3 natural log of 2, and this would actually give you negative 6 natural log of 2. So together, those two would give you negative 9 natural log of 2. Plus 3 natural log of 5. Clean that 3 up just a hair. plus natural log of 7. Okay, so all those little pesky rules of logarithms sneak back here. So if you actually got to this part and it was multiple choice and you didn't see the right answer there, you'll kind of have to mess around with it a little bit. All right, so any questions on that one? Yes.
Was that LN7 at the end of that?
Yes. Let's see if I can clean it up a little bit. Yep, so natural log of 7. All right, any other questions on this one? Okay, oop, you can still write in. Oh, you're still writing? Yep. All right, so let's say if we have 5x plus 1 or 6x squared plus 7x minus 3 with respect to x. Okay, so we know that 6x squared plus 7x minus 3 is actually equal to 2x plus 3 times 3x minus 1, okay, which are non-repeating linear. Okay, so we just rewrite it. 5x plus 1 or 6x squared plus 7, oh, might as well go ahead and write it, factor it out, since we already know what it is. 2x plus 3 times 3x minus 1 equals a over 2x plus 3 plus b over 3x minus 1. Okay, so just like before, we want to get our common denominators. Okay, so that means we have our 5x plus 1 over 2x plus 3 times 3x minus 1. Give it a little bit of space. A over 2x plus 3, b over 3x minus 1. Multiply this one by 3x minus 1 over 3x minus 1. And this one by 2x plus 3 over 2x plus 3. Oh, clean that 3 up a little bit. Okay, so we know if we multiply it all the way across by the common denominator, those all three would disappear. So that leaves us with 5x plus 1 equals a times 3x minus 1 plus b times 2x plus 3. So again, using strategic substitution, we let x equal 1/3. Okay, so really all you're looking for, whatever value that will make 3x minus 1 equals 0, which is 1/3. Okay, so that's 5 times 1/3. Uh-oh, can you make that a little bit bigger? Plus 1 equals a times 3 times 1/3 minus 1 plus b 2 times 1/3 plus 3. Okay, so 5 over 3 plus, well, actually if you wanted to, yep, 5 over 3 plus 1. So 5 over 3 plus 3 over 3 will give you 8 over 3. Equals 1/3. 3 times 1/3 is just 1, so that disappears because that becomes 0. So b, 2/3 plus 3 over 3, so 2/3 plus 9/3 is 11 over 3. So you have 11 over 3b. Okay, so multiply both sides by 3 over 11. B equals 8 over 11. Okay, so we solve for B. Now we do the exact same thing to solve for A. Okay, so we want 2x plus 3 to equal 0, so we make x equal negative 3 over 2. And again, you don't have to try and figure out what to put there. All you have to do, 2x plus 3 equals 0. Negative 3 over 2. Okay, so if we make x equal negative 3 over 2, that means we have 5 times negative 3 over 2 plus 1 equals a times 3 times negative 3 over 2 minus 1 plus b 2 times negative 3 over 2 plus 3. Okay, so if you did everything correctly, that should disappear. So you should have negative 15 over 2 plus 2 over 2. So that should be negative 13 over 2 equals a. So you have negative 9 over 2 minus 1. So negative 9 over 2 minus 2 over 2 would be negative 11 over 2. Uh-oh. So negative 11 over 2a. Okay, multiply both sides by negative 2 over 11. 2's cancel out, so you end up with a equals 13 over 11. Okay, so now, instead of integrating what's up here, we're going to integrate those two terms. So the integral of a, if you want, you can just put it right in front instead of on top. You can do that. Just a lot easier sometimes. So 1311 times 1 over 2x plus 3 plus 8 over 11 times 1 over 3x minus 1 with respect to x. Okay, so for this one, since you can't just do u prime over u, we'll let u equal 2x plus 3, which means our du would equal 2 dx, which means our dx would equal du over 2. Oh, forgot my, oh no I didn't. Okay. So now we'll do the same thing for the other term. Let u equal 3x minus 1, which means our du, or our dx, is going to equal du over 3. Okay, so I don't think I have enough room to finish this, so I'll leave this up for a few minutes and finish it up on another sheet. Alright, so finishing this up. Okay, so that gives us 13 over 11 times, say du over 2 divided by u, plus 8 over 11 times du over 3 divided by u. Oh, I already did those. Don't need to write that again. And so here we just bring our 1/2 down to the front. So you have 13 over 22. Oh, don't need this now. Times the integral of du over u. Remember, for this one, the u's are different for both.
So
Plus,
U1 and U2.
yeah, that may be a little bit easier, just to avoid confusion. u1 and u2.
Or the letter.
There we go. u1 and u2. Okay, so bring down our 1/3. You will actually, it looks a little bit congested there. So that's 8 over 33 du over u, which just gives us 13 over 22. The natural log of u1 was, I think, 2x plus 3. Yep, 2x plus 3 plus 8 over 33 times the natural log of 3x minus 1 plus c. Okay, and that would be your final answer. All right, so any questions on that one?
Yes, actually.
Mm-hmm.
Is there a case that happens where the p of x in the numerator is more than just an exponent of 1, so to speak?
What do you mean more than the exponent?
For example, the one that we did was just, in this case, it was a first degree polynomial. There was only just x.
Oh, you mean,
squared.
so if you have like x squared over x cubed?
Yeah.
Yeah, there's some cases, though they kind of build up a little bit later.
Then how does that translate into the rule, so to speak?
It all depends on the denominator. If you have a repeating denominator, then it's a different approach. But if it's non-repeating, you use this approach. If it's improper, then if it's improper and it's, like, say, x to the fourth over x to the third, then you can just divide like we did before.
Okay.
So, kind of varies in approach. All right. So let's say, for example, let's say if we want to find the value of the integral from 1 to 2, 2x squared plus 3 over 2x squared minus x. Okay, so the degrees are equal, so technically this is an improper fraction. Okay, so since it's an improper fraction, you divide. The only drawback is you can't use synthetic division. Okay, so you have to divide the old-fashioned way. Okay, so you have 2x squared. Oh, quick side note. You want to remember the exponents have to be, not the exponents, the exponents have to be in either descending order or ascending order, depending on which direction you're going. But they have to be in descending order. You're going from left to right. So 2x squared plus 3, you have to write that as 2x squared plus 0x plus 3. Exponents in, well, must be in descending order. Should be able to fit there. Okay, so that means we have 2x squared plus 0x plus 3 divided by 2x squared minus x. Okay, so the first thing we want to do is get rid of our 2x squared. Okay, so 2x squared times 1 would actually give us 2x squared. So 1 times 2x squared is 2x squared. 1 times negative x is negative x. And we subtract. 2x squared minus 2x squared is 0, so that worked out. 0x, remember that becomes plus x, is x. And we bring down the next term. Okay, so that means 2x squared plus 3 divided by 2x squared minus x actually equals 1 plus x plus 3 over 2x squared minus x. Okay. Or you can actually write it as 1 plus x plus 3, if we factor out an x here, x times 2x minus 1. Okay. Now the first one worked out by just becoming 1.